Welcome to this Big Data and Hadoop tutorial series presented by COSO IT. In this video, we are going to focus on Mapreduce 2 or YARN. In this lecture video, we'll be talking about YARN overview. What is YARN? We'll be seeing what is Mapreduce 1 execution framework. We'll be talking about YARN architecture and its components. Then what is Mapreduce 2? And how does it look like running a word count application in Mapreduce 2? So YARN is a core component of Hadoop 2 and is added to provide improved performance in the Hadoop world. YARN is the next generation of Hadoop's computing platform, which offers various advantages as compared to classic Mapreduce engine in the first version of Hadoop. So let us see in detail what is YARN and what advantages does it offer over classic Mapreduce. YARN stands for Yet Another Resource Negotiator, and it has been introduced in Hadoop 2. As its name suggests, it is the layer that separates the resource management layer and the processing components layer. So it is basically separating the resource management layer and the processing components layer, which in earlier version was binded in one layer. So Mapreduce version 2 is simply the re-implementation of classical Mapreduce engine, now called Mapreduce version 1, that runs on top of YARN. So YARN is basically taking the function of resource management apart from the Mapreduce processing. So before learning the benefits of YARN or the limitations of Mapreduce version 1, let us see the Mapreduce 1 execution framework. We have a master node called job tracker, which is responsible to assign and track task execution progress. Then we have the slave daemons called task trackers, and they run on systems where data nodes reside. They are responsible to spawn a child JVM to execute Mapreduce and other intermediate tasks. So in Mapreduce 1, job tracker takes care of both job scheduling and task progress monitoring. Let us see the motivation behind Mapreduce version 2, or what are the limitations of Mapreduce version 1. First is the scalability bottleneck. So the large Hadoop clusters reveal the limitation involving a scalability bottleneck caused by having a single job tracker. And according to Yahoo, the practical limits of such a design are reached with a cluster of 5,000 nodes and 40,000 tasks running concurrently. Another problem it faced was that the computational resources on each slave nodes are divided by a cluster administrator into a fixed number of map and reduce slots. So a node can't run more map tasks than map slots at any given moment, even if no reduced tasks are running. So this is not the proper utilization of resources. Another most important problem was that Hadoop was designed to run Mapreduce jobs only. So job tracker is an application which is built for Mapreduce framework only, and the problem arises when a non-Mapreduce application tries to run in this framework. So YARN opens up Hadoop to other types of distributed applications beyond Mapreduce. YARN was introduced to overcome these problems, and YARN brings in the concept of a central resource management. Coming on to YARN architecture, we can see that in YARN architecture, global resource manager runs on a master daemon, and it tracks how many live nodes and resources are available. So basically, job tracker 1 responsibility is now split into two. The resource manager, which manages the resource allocation in the cluster, and the application master that manages resource needs of individual applications. And there's something called node manager, which is a generalized task tracker. So node manager provides computational resources in form of containers and manages processes running in those containers. And the container executes an application specific process. So we can see that in Mapreduce 1, job tracker takes care of both job scheduling and task progress monitoring. But in case of Yarn, these responsibilities are handled by separate entities, the resource manager and an application master. So if we see the Yarn components present in this diagram, we have client which submits the Mapreduce job, the resource manager which is used to manage the use of resources across the cluster. So it is the ultimate authority in resource allocation. The container, that is you can say a package of resources including RAM, CPU, network and hard disk, etc., which can run different types of tasks like map task or a reduce task. Then the node manager. Node manager is used to oversee the containers running on the cluster nodes. And the application master, it negotiates with the resource manager for resources and runs the application specific processes like map or reduce tasks in those clusters. Now let us see these components one by one. These are the Yarn daemons. The resource manager has two components, scheduler and application manager. It is a global resource scheduler and it manages and allocates cluster resources. Resource manager is responsible for tracking the resources in cluster and also scheduling the applications like Mapreduce task. Then the application master. It manages application lifecycle and task scheduling. It can interact with resource manager as well as the node manager. An application we can say is a job submitted to the framework, for example, the Mapreduce job. The application master and Mapreduce task run in containers that are scheduled by resource manager and then managed by the node manager. Then the node manager. Node manager manages run on all nodes in clusters to launch and monitor containers. It doesn't matter if the container is created for map or reduce or any other process. Node manager ensures that the application doesn't use more resources than what it is allocated with. Container or slot. Containers are important Yarn concept because container is a request to hold resources on Yarn cluster. So it is a basic unit of allocation. For example, container can be said of having 2 GB and 1 CPU. So what is Mapreduce 2? With Yarn, there is no longer a single job tracker to run jobs and a task tracker to run tasks of the jobs. The old Mapreduce framework is now rewritten to run with the submitted application on top of Yarn, and this application is now renamed as Mapreduce 2 or Mapreduce version 2. It is the same Mapreduce execution you have been working with, except that each job now controls its own destiny through its own application master, taking care of execution flow such as scheduling tasks, handling speculative execution and failures, etc. It's a more isolated and scalable model than the Mapreduce 1 system, where there was only one job tracker who did all the resource management, scheduling and task monitoring work. Let us see how our word count application is run in Mapreduce 2. So we see here there is one resource manager, the master node, then the slave nodes have on data nodes, we have node managers. So in HDFS, we have a file, my data, on which we want to perform word count job. And its data is stored across two nodes, data node 1 and data node 2. Now to run an application on Yarn, a client contacts the resource manager and asks it to run an application master process. The resource manager then finds a node manager that can launch the Mapreduce application master in a container. Now the Mapreduce application master requests for resources from resource manager, and finally it launches containers on the data nodes, which can be any of the data nodes, launches the containers for the Mapreduce tasks. The application master and the Mapreduce task run in containers that are scheduled by the resource manager and are managed by the node manager. Same way, word count reduce tasks are also generated, launched by Mapreduce app master on the containers. So if you see on higher level, there are 5 independent entities: client, which submits the Mapreduce job, then the Yarn resource manager, which coordinates the allocation of computer resources on the cluster, then the Yarn node manager, which launches and monitors the compute containers on machines in the cluster, and the application master, which coordinates the task running the Mapreduce jobs. And finally, the HDFS, the distributed file system, which is used for sharing job files between the other entities. Thanks a lot for watching our Yarn or Mapreduce tutorial. For more tutorials, please subscribe to our YouTube channel or register for in-depth big data training with our real-time cluster on www.cosoit.com.